Hello and welcome. In this video, we're going to review some things from geometry, such as sine, cosine, and tangent. We're going to add in the inverses of those three trig functions so that we can actually talk about all 6 trig functions and how we can use them to solve a right triangle, how we can use different pieces of them to find angles or to find side lengths, and how to apply that in context for situations involving angle of elevation and angle of depression. So let's go ahead and jump right in. So in geometry, you learn about sine, cosine, and tangent, and how we can find sine, cosine, and tangent based on different side lengths of a right triangle. So if we have a right triangle and we have a given angle, theta, we can identify which side is opposite, which side is adjacent, and which side is the hypotenuse. So just as a reminder, the hypotenuse is always going to be opposite the right angle. The opposite side is always going to be if you took theta and you walked across and hit the other side, the side that's opposite, that's where you're going to get opposite. And adjacent is the side that's touching the angle theta, that's not the hypotenuse. So as long as we know those 3 side lengths, we can use the fact that sine is opposite over hypotenuse, that cosine is adjacent over hypotenuse, and that tangent of theta is opposite over adjacent. And you may have learned in previous classes the expression SOHCAHTOA, which allows you to sort of memorize an acronym that helps you remember which side lengths go with which trig function. What we're going to add in this class is that each of those functions, sine, cosine, and tangent, each of them have an inverse function. So sine goes with cosecant. That's what this CSC stands for. It stands for cosecant. And cosecant, being the inverse of sine, means that we're going to reciprocate those 2 side lengths. So instead of opposite over hypotenuse, which is how you find sine, cosecant is going to be hypotenuse over opposite. The next one, cosine, is going to go with secant. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. So you're reciprocating the side lengths. And lastly, tangent is opposite over adjacent. So cotangent is adjacent over opposite. One of the ways that I help keep track of which ones go together, tangent and cotangent both have the word tangent in them, so I think that one's pretty simple to remember. But sine and cosecant and cosine and secant, I just always remember that the same letter never goes together. So S and C, S and C. So the same letter never goes together. Okay, so let's look at this right triangle. Let's identify which side is opposite, which side is adjacent, which side is hypotenuse from the angle that we are going to be looking at. And then let's go ahead and find each of the first 3 trig functions, which we're reviewing, and then reciprocate them to find the inverses. So we're going to use angle A as our theta. So I'm going to write theta in here. From that angle, our opposite side is 8. Our adjacent side is 15, the side that's touching angle A, but not the hypotenuse, because the hypotenuse is always the longest side, which is across from the right angle. So if sine is opposite over hypotenuse, that means that sine is 8 over 17. Cosine, being adjacent over hypotenuse, is going to be 15 over 17. And then tangent, being opposite over adjacent, is going to be 8 over 15. So that should be review from geometry. The new portion now is that for cosecant, we're going to take the reciprocal of sine. So sine was 17 over 8. So now cosecant is going to be, sine was 8 over 17, so cosecant is going to be 17 over 8. Cosine was 15 over 17, so cosecant is going to be 17 over 15. Tangent was 8 over 15, so cotangent is going to be 15 over 8. So again, we're just taking the reciprocal of each of those side lengths to find our inverse trig functions. So now we have identified all 6 trig functions based on the angle A. Let's go ahead and look at some more examples like this. All right, for example 1, we're going to be using theta for each of these angles. So again, I actually want you to pause the video. On example 1, I want you to first identify which side is opposite, which side is adjacent, and which side is hypotenuse. And there we have it. I'm noticing that these are all even numbers, so we're actually going to have to do a little bit of fraction simplification as we work through these problems as well. So sine of theta, opposite over hypotenuse, that's going to be 24 over 40, but I need to simplify that and rewrite this. So sine of theta, both of those are divisible by 8. If I divide 24 by 8, I get 3. 40 divided by 8, I get 5. So sine of theta is going to be 3 over 5. What does that mean that cosecant of theta is? That's right. All we have to do is reciprocate that. So cosecant of theta is going to be 5 over 3. Cosine of theta is going to be adjacent, which is 32, over hypotenuse, which is 40. That is also going to simplify. So cosine of theta is going to be, both of those are divisible by 8, so 4 over 5. Which means that secant of theta is going to be the reciprocal of cosine, which is 5 over 4. Tangent of theta is going to be opposite over adjacent, so 24 over 32. Again, we can divide both of those by 8 to simplify to get 3 over 4, which means that cotangent is going to be 4 over 3. I want you to go ahead and pause the video and work through number 2 on your own, and then unpause the video and see how you did. So 5 is opposite, 12 is adjacent, 13 is hypotenuse, and now we can identify each of those 6 trig functions. All right, number 3, we're not given the picture of a triangle, but we could go ahead and draw it. So let's start with what we know. We're going to be asked to find all 6 trig functions, so I'm going to go ahead and write them. And I like to write the inverses right next to the function itself because I think it makes it easier to remember which ones go together. So I'm going to go ahead and write each of those here. I'm going to write what we know. We know that sine is 4 over 5, which means we also know that cosecant is just the reciprocal of that. But how do we find the other 3? Well, let's get a triangle in here. Let's pick an angle to be theta. If sine is opposite over hypotenuse, that means this side is 4 because it's opposite that angle, and this is the hypotenuse. And we can do the Pythagorean theorem to find this bottom length. So 5 squared equals 4 squared plus b squared. B is going to end up being 3. So now we have all the side lengths. So the key difference between 1 and 2 versus this example number 3 is we may have to actually draw a triangle, maybe have to use the Pythagorean theorem to find the indicated side length. So go ahead and pause the video and identify each of these remaining trig functions. So in this case, cosine is going to be 3 over 5 because 3 is adjacent, which means that secant is going to be 5 over 3. Tangent is going to be opposite over adjacent, which is 4 over 3, which means cotangent is going to be adjacent over opposite, which is 3 over 4. So now that we've gotten this idea of how to use an indicated angle to identify the 6 trig functions, let's talk about how to use some of those 6 trig functions to identify what an actual angle is. All right, so go ahead and grab a scientific calculator if you have one. But what I want you to see is if we know that sine of theta is root 2 over 2, there's actually a way on our calculator for us to figure out what theta is. So to find the missing angle, we're talking about how do we find theta. So what we can do on our calculator is we can say sine inverse, which you can see that button here, sine inverse of root 2 over 2 equals, and then it will spit out our indicated angle. So if I type sine inverse, which might show up as arcsine of, I'm going to put another set of parentheses, the square root of 2 divided by 2, that's going to give me the angle 45 degrees. Now be careful, we're going to talk about in the next section what a radian is, but if right now we're going to be looking at our angles in degrees, so you need to make sure your calculator is in the mode for degrees, as opposed to this mode that says rad, that would be radian mode. So you're going to need to check and make sure your calculator is in the right mode. Okay, the hardest part about these sections is actually really just taking a minute to figure out what trig function do I need to use, because sometimes there's more than one that we can use, to find the indicated angle. So technically on number 4, we have two sides of a triangle, of a right triangle, which means we could use the Pythagorean theorem to find the third side. However, that just means we're going to have to do more work. So what I really want to think about is if theta is here, what two pieces of information do I have? Well, 5 is opposite theta. 19 is the hypotenuse of theta. What trig identity, or sorry, which trig function uses opposite and hypotenuse? Well, that's sine. So I'm going to use sine of theta is going to equal 5 over 19. Now, if I wanted to use cosine, I would just need to find this side length. If I wanted to use tangent, I would need to find that side length. So sine of theta is 5 over 19. What that means is inverse sine of 5 over 19 will tell me what theta is. So let's go ahead and try that. So I'm going to hit inverse sine 5 divided by 19 equals, and that's going to give me 15.257. So let's go ahead and just round that to 15 degrees. We're going to say theta is approximately 15 degrees. So why don't you go ahead and look at number 5, try and figure out which of the side lengths you have with respect to this angle here, so that you can identify if you should use sine, cosine, or tangent to set up your statement, and then practice using your calculator to find that actual value. So we know opposite and adjacent. We don't know the hypotenuse. Yes, we could find it, but we don't know it right now. So we're going to use tangent. So we're going to push tan inverse of 20 over 43 to figure out what our angle theta is. And that's going to give us that theta is approximately 24.943. So let's say theta is approximately 25 degrees. Okay, now let's talk about tying these two ideas together using those 6 trig functions, finding different side and angle lengths, to talk about what it means to solve a triangle. To solve a triangle just means to find all the sides and all the angles. This is something that you should have learned in geometry. So we just talked about how to find an angle if one was missing, and we know that all the angles in a triangle add up to be 180 degrees. So as long as we have our 90-degree angle from our right triangle and we have one other angle, we can find the angle that is missing. To find the side lengths, we can now use different trig functions to solve for indicated values. We can also keep the Pythagorean theorem in mind. So let's talk about angles first. If we look at number 6, we have the right angle, we have the 28-degree angle, which means to find the measure of angle B, we just need to do 90 minus 28, or 180 minus 90 minus 28. That's going to give us that the measure of angle B is equal to 62 degrees. Why don't you go ahead and find the missing angle on number 7? All right, number 7 isn't labeled well, so I'm going to call this theta. So the measure of angle theta is going to be 90 minus 60, which is going to be 30 degrees. Okay, now to find the side lengths B, C, and A, depending on what we are given, we can use any trig function that we like. We can also use either of the angles that we have. So I like to set up trig functions where the variable that I'm solving for is not in the denominator. So when I look at trying to find A here, I'm thinking that I could probably use tangent, because tangent of 28 would give me A over 15, which means that A would be my only variable. So tangent of 28 degrees is going to equal A over 15, which means that A is going to be 15 times the tangent of 28 degrees, which I can grab my calculator for. When you do that, you're going to get that A is approximately 7.975, and the directions here are going to tell us to round to the nearest integer, so we're going to say that A is approximately 8. And if we have two sides of a right triangle, how do we find the third? Well, we can just use the Pythagorean theorem. 8 squared plus 15 squared is going to equal c squared. So c squared is going to be 289. So c is going to be 17. So we have solved the right triangle because we now know the value of all the side lengths and all of the angles. For number 7, you can do this the same way using either of the angles. So why don't you go ahead and pause the video, decide if you want to use sine, cosine, or tangent. I think tangent's a great option, again, if you're going to use theta here, the 30-degree one, to find your opposite and your adjacent. Then unpause the video and see how you did. All right, we can say tangent of 30 degrees is going to equal b over 10. So b is going to equal 10 times tangent of 30, which is going to give us 5.7735, or this is going to give us approximately 6, since it does say round to the nearest integer, which means now we can find the other side. 6 squared plus 10 squared equals a squared, according to the picture. That's going to give us that a is the square root of 136, which means that a is approximately 11.66, or we can say a is approximately 12. So we have found all of the side lengths. B is approximately 6, a is approximately 12. We already knew the other side was 10, and we have our three angles, 90, 60, and 30. Something that I do want to point out about number 7 is that this was a special right triangle. So you could use special right triangles to find the different side lengths. If we know that 10 is the longer side, we know that 10 is equal to the shorter side times the square root of 3 based on special right triangles, which means that b is 10 over the square root of 3, except we never leave radicals in the denominator, so we need to multiply by root 3 over 3. So that would give us our value for b. We also know that a is 2 times b. In this case, the hypotenuse is twice the length of the shorter side, which means that 10 can just become a 20. So don't forget what you have learned in previous classes. They can oftentimes make your life a lot easier. Let's look at one last topic, angle of elevation and angle of depression. So the angle of elevation is the angle between the sight line moving upwards towards an object. So if you're standing on the ground looking up at the mountain, that angle that you're forming would be your angle of elevation. Versus if you're looking downwards towards something in the same way, that would be your angle of depression, because it's depressing, it's going down. If we have a problem that involves using the angle of elevation or using the angle of depression, the best idea that I have for you is to just sketch a picture and then use all of the different skills that we've discussed in this video to help you figure out what the question is that's being asked and how to solve it. A 5-foot person is standing, so 5 feet, 20 feet away from a tree, and measures the angle of elevation, so this angle from their sight line up to the top of the tree, to be 38 degrees. How tall is the tree? So something I want you to recognize is we know that the tree's height is 5 plus whatever this distance is. I'm just going to call it x. So we can use this angle of 38 degrees to sort of look at a triangle here, a right triangle, to find x, and then at the end we're going to need to add 5 to figure out what that length is. So if we know the base of the triangle is 20 and we know the angle is 38, we want to talk about the opposite side. So we're really saying 38, x, and 20. Which trig function is going to help us find that? It's going to be tangent. So tangent of 38 degrees is going to be x over 20. So x is going to be 20 times tangent of 38 degrees, which we can grab a calculator for. That's going to give us 15.36 feet. But we need to add 5 to that to find the total height of the tree. So the height of the tree is 20.36 feet. Because remember, this length is how much they're seeing from their sight line, but we need to include the 5 feet of their height in that total length. So go ahead and pause the video and try and work through number 9 on your own, and then unpause the video and see how you did. All right, hopefully you had time to draw some sort of picture. We have an 80-foot hypotenuse here. We're looking at the height. This is a 31-degree angle. So in this case, I think sine of 31 giving us h over 81. H over 80 is going to make the most sense here because we are looking for the opposite and we want the hypotenuse. Here we're just being asked how high above the boat is it, so we don't have to worry about this extra factor like we did on number 8 of 5. So h is going to be 80 times sine of 31 degrees. So the height that we are above the boat, or that the parasailer is above the boat, is 80 times sine of 30 degrees, which is 41.20 feet, and we should write that in a complete sentence. And we're done. So let's recap what we covered in this video. We talked about not just the 3 trig functions that you should have learned in geometry, but those 3 and their inverses. So the 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. Then we reviewed how to identify opposite, adjacent, and hypotenuse so that we could evaluate each of those 6 trig functions given a triangle and an angle that we're doing that with respect to. We talked about how to use our calculator to find an angle using the inverse buttons and making sure that our calculator is in the appropriate mode. In this case today, it needed to be in degrees mode. We reviewed what it means to solve a triangle, finding all of the side lengths and all of the angle values. And we did a little bit of review into a 30, 60, 90 triangle. And then lastly, we tied this together talking about angle of elevation and depression, drawing a picture, making sure we know what value we're looking for, and setting up a trig function to help us find that. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.